A researcher tests the braking distances of several cars. The braking distance from 60 miles per hour to a complete stop on a dry pavement is measured in feet. In other words, if you're traveling at 60 miles an hour and you have to slam on your brakes, your car doesn't stop right there, right? You travel for a little bit before your car finally stops. Hopefully it stops before you need to, before you hit something. That's your braking distance. Your braking distances are normally distributed with a mean of 129 feet, which is why they tell you how many lengths of cars you need between you and another car. Usually, every 10 miles per hour, you need another car length in front of you. So if it's 60 miles an hour, you're supposed to have 6 car lengths in front of you. Because if you slam on your brakes and you hit that person in front of you, it is your, if they slam on their brakes, and you have to, and you hit them, it is your fault. So technically, you need to leave a car length for every 10 miles an hour because your car doesn't stop when you hit the brake. It has a braking distance before it stops. So the average car brake distance is normally distributed with a mean of 129 and a standard deviation of 5.18 feet. What is the longest braking distance that a car, could have and still be in the bottom 1%? Now, let's think this out. Let's make a chart. Let's make our sketch. I want to see if you think like me. Put your mean here and add your standard deviations all the way up. Make sure you're making this with me. I want everybody to understand this. Okay, everybody's finding this? You okay?
What's that?
134.18. I added 5.18 all the way up and subtracted it all the way down.
Is that 118.64?
118.64.
She's all under your stomach, man. Oh, no.
No, what was that?
Oh, no, I said something.
Oh, okay. Well, let's see where that 0.01 falls. This is where I disagree with your book. We want to know where is the bottom 1% of your curve. Over on the left. I would find the bottom over on the left. I would find it over here. The bottom 1%. Agree? Well, it's a negative z-score. It's a negative side. You're at the you want the bottom 1%. You only want 1% to the left of your answer. Okay, so let's see. So I need to take this area. This is my area over here, and I need to find a z-score for it. So inverse norm, 0.01, and find me your z-score. 2 decimal places. It's got to be really, really small out there, doesn't it? What is it?
Standard deviation, you keep that 0 and 1, right?
You keep the 0 and the 1. I'm going to show you in a minute where you don't have to. But negative 2.33, which makes sense, doesn't it? Shouldn't it be all the way over there?
Yeah.
Okay, then we're going to take your formula to find the value that is associated with that z-score. I know approximately where it should be. It should be between those two values. So I plug this in. The negative takes care of it, your standard deviation plus your mean. Plug that whole thing into your calculator and tell me what that x value is. Round it to 2 decimals. Since the rest of our chart is rounded to 2 decimals. 93 what?
Oh, six.
Okay, now, your rounding says it has to be within this piece. So therefore, no matter what it is, I have to round down. 93.06, yes, it naturally falls that I will round down. But if it was 93.66, I would still have to round down because rounding up would put me out of that.
So we're always
Shading.
rounding down?
No, we have to look. You have to look at where your shading goes. Because watch, here's 116.9306. Here's 116.966. Now, if I round up, I'm out of my shading. See it? I've got to round down into my shading. This is where you have to look at your sketch to see where to round. You still round down. You got to bring it into this.
But how would you know?
You have to look at your shading. If they wanted 2 decimals on this because they gave you a standard deviation of 2 decimals. This is your cutoff right here, this bar. This is at what you found, 116.9306. Now we're going to round that down so that it stays in this shaded area. It can't pass that shaded area. If you round it up, you went past that shaded area. So you have to round into that shaded area. That's where the shading comes into play. Now, here's my problem. Is it better to have a long breaking distance or a short breaking distance? A short breaking distance. So the bottom of this curve should actually be where? Okay, if I'm rating my braking system, and I would rather stop in a shorter time than a longer time, the bottom of my barrel here should be probably stopping not so good, right? The top of my chart should be stopping real fast. Should be your best. If you think about it, it's not like wearing your tires in your cars and things like that. It's your braking distance. You want
So you want to be
a
farther.
smaller. I would say my bottom has to be up here. Because isn't that the longer braking distance? Now, the old book for this, they did that way, but the new book didn't. The old book kind of mixed it up, but I don't understand why. But, I mean, I'm fine with it this way. This is what your book says. But I, personally, would say the bottom of this list is a longer braking distance. You don't want to be down there. Don't you want to be at the top of this list?
Yeah.
You want to be at the shorter braking distance. So, if we do this to satisfy me, and I'm looking for this 1%, let's use what we have. What would this z-score be? I want you to think about it first. Good. 2.33. Because your curve has symmetry, right? About the mean. It's the same distance to the left as it is to the right. So all I would have to do is take that positive. I just want you to stay with me because this is something you guys need to evaluate. And put this in your calculator. What do you get?
0694.
Okay, now we have to round this. This is a good example. We have to round this to 2 decimal positions. Okay, but I want you to look here.
Round up,
This-
right?
This guy says you're going to have to round up, doesn't it?
That guy.
You have to put me into that shaded area.
The guy over here.
Yes, x is equal to 1. That guy right there said that. Round up. Round up into that shaded area. Now, that's on the positive side. Well, only because here's your cutoff at that exact number. If you round down, aren't you to the left of it? Because these numbers go, from 0 to, increasing. If you round up, doesn't that put you into it, the shaded area?
Oh wait, which one is the right?
Well, I'm right.
Which one's gonna save
The
us?
book is wrong.
So
Which one is gonna keep us alive?
did you do?
What would keep you alive? This is me. I would do the green. I would say the bottom of this is the slower braking distance. It goes exactly opposite of what you would think. The book does traditional. Here's your bottom. Let me take 1% off the bottom.
Let's do that.
Yes, you can. I wouldn't give you this as a problem because it kind of, you have to think about it though. Like, in this case, it's better to have a smaller number than it is a larger number. To me, it would be. For your braking distance, you would rather stop in 100 feet than 200 feet, right? If it takes you 141 feet to stop versus 100 and, what did this one come out to be? 116 feet to stop. Which one would you rather stop in? 116 feet or 140 feet? 116, that's at least another car length or more, right? Wouldn't you think? So to me, the bottom would be the longer braking distance. Do you guys see where I'm coming from?
Yeah, I'm trying to keep us alive.
I feel you.
Yeah, that's what I want you to do. But can we understand it both ways?
Yeah, I'm gonna be further.
You want to stop in a shorter distance.
If you're braking, you have a better chance of being farther. Like, without hitting them.
Like the bottom of, like, okay, let's compare this to grades. If I'm comparing this to your grades, and I said 70 was average, and we went up 5, shh, guys, I need you to focus on this. And I went up with a standard deviation of 5. Would you rather have, and I said, where's the bottom 1% lying? My bottom 1% is failing, isn't it? Wouldn't you rather be in the top 1%? And that has no problem with this problem. If I would look to my bottom 1%, I would do it exactly the way this problem was. Where's the top 1%? Up here, right? You want a higher grade. Now the only difference with this is braking distances are better to be smaller than larger. So it kind of reverses the thinking of it.
So basically, you want, but you can't like put the numbers like lower to the right.
No, it has to increase this way. It has to go from lowest to highest. It reads like a number line.
It would just be common sense that you would think like, oh, braking distance more.
You want to be shorter, right? Not so much common sense because what happens is everybody hears bottom. They say, oh, bottom down here, which is what your book did. Now the old book did it correctly. It did the top. But the new edition, this one is doing the bottom. And maybe it did this because it didn't want to confuse anybody else. So, but I need you to think about it. I need you to think which one would be better.
So if this is like top 1%, and you would go to the negative sign?
No, the top is going to be up here. For your braking questions? For your top 1%? Yeah, you want to be the low guy. Just for the braking distances, it was backwards. But normally it is the top 99% of the time. The top is the right-hand side. 99% of the time. Okay, let's try one more together, guys. Come on, focus here. Okay, this brings us back to where we were. Okay, in a randomly selected sample of women 20 to 34, the mean cholesterol level is 181 milligrams per deciliter. So we're going to pull this out with a standard deviation of 37.6. Okay, so you're going to assume they are normally distributed. You're going to find the highest cholesterol level that a woman in this age group can have, but be in the bottom 1% of her field. Now, this is their true bottom. So we're going to separate this again. We're going to put your mean out here. And we're going to add 37.6 all the way up. We're going to subtract 37.6 all the way down. There's a bigger discrepancy in cholesterol levels, obviously. Because look at your standard deviation, 37. That's a big difference. So we're going to put this all the way up. This is some really high cholesterol levels. And then we're going to come all the way down. Remember, this has to be in order. This is 143. I don't think you can read this. God bless you. God bless you. That's this guy right here. And I think the opposite side has too low a cholesterol level. Okay, so our cholesterol levels are standing from 68.2 to 293.8. I want the bottom 1%. Now, being low and being really that high are the same equivalent. So our bottom 1% is here. Now, you guys already found the 0.01, right? What was that Z-score? Good. Therefore, all we have to do is plug this into your formula. So you've got a negative 2.33 times your standard deviation plus your mean. That negative puts you to the left of your zero. Okay? So it'll subtract that off your mean. So what do we get? And give me like 3 decimal places.
3.39.
Okay? Now, where should I round? That's my cutoff, right here. My cutoff is 93.392. I want to go down to 1 decimal place. But I want to be inside this shaded area. Where do I have to go?
Round down.
Round down. I got to be 93.3. Do you see why we're rounding down? Now I think your book also does this part wrong too.
So if actually the top 1% will round up.
Yes, then you would round into that shaded area.
Or
Yeah.
But if they're whole numbers, like, then you just do, if it was 93.4, you just go, or like 93.6, then it's a whole number, you just go back down again.
You can actually leave that 1 decimal. I noticed that the book went 2 decimals. They went to 93.39. Oh, okay, I'm sorry.
I said if it was a whole number,
If you ended up with a whole number like 93,
or if all your numbers were whole numbers, like, if it was 93.6, you still go down 93.
yes, you'd be 93. Now, let me show you a little trick on your calculator. You know how you did inverse norm? And let me make space. You put inverse norm. You said, find me my area. You had your mean is 0. Your standard deviation was 1. You found your z-score. Right? Okay. We can do the same thing we did with your normal PDF, with your PDF guide. We could say inverse norm. 0.01 is your area, but your mean is 181, and your standard deviation is 38.6. Try that. Tell me what you get. 37.6, right?
Yeah.
Try that. And tell me if you get 93.39, something like that. This will find your X value.
93.5.
Yeah, it's a little bit different rounding. So what did you get?
93.5. Keep going on.
No, that's fine. Now,
What's in the area?
well, you still have your 0.01. This was the same as when we bypassed your z-score using your normal PDF one. You can do this with your inverse norm. You can change your mean and your standard deviation to match your scenario. And in that case, it brings you back that X value. However, we rounded when we found this. But your calculator doesn't round. And we can bypass all of that.
By doing that, you're skipping a step.
You're skipping this step and you're skipping this step. But you're still sketching because you still have to count. Because I want you to know how to do it first. Because what happens is, if you don't do that part right, then you're in trouble. Okay, guys, write this down. You can snapshot your book.